Okay, so many of you struggled with example 2.14, letter D, which I'll walk you through here in this video. This one's a pretty tough one to see. I suspect by looking at it that I'm trying to convert this into a format that's 1 on x squared plus a squared in order to use the inverse tan integration. So that leads me to believe that perhaps since this doesn't factor into a perfect square, the only way to get this to factor into a perfect square, when I'm talking about this, I'm talking about the denominator here, is by completing the square. So x squared plus 6x plus what will get me something that's a perfect square. And so that's where we find the value of b, which is 6, divide it by 2, which is 3, and square it, which is 9. But I can't just add 9. So one way to think of simply adding 9 is adding 9 and subtracting 9, because I'm really not actually changing the numeric value of the denominator. So then the first 3 terms, that will factor into a perfect square. So x plus 3 quantity squared, and then the last 2 terms, minus 9 plus 1, simplifies into plus 1. So that's one way to think of it. Some people might think of borrowing 9 from the value of 10 and splitting it into 9 and then plus 1 in order to rearrange the denominator so you get something that's quantity squared plus a squared. So now this is simply a matter of recognizing that I can identify that u is the x plus 3 and du would be 1 dx, and so it fits the inverse tan perfectly, where it's the inverse tan of x plus 3, and a is 1, so plus c. And it's a pretty beautiful problem, but it's difficult to get started. What will be more challenging is when it's just practice of all sorts of integration and trying to determine which category of integration the problem fits into. So at some point in time we'll do an integration B, where we'll try and do some integration of all different types of integrands.